Hello there folks, welcome to video number 118. This video is on percentage and simple interest. So the keywords are simple interest, percent and annum. So simple interest is something that you can either pay on a loan and it's calculated on a specific time period, or it's something that you can earn if you've got money in a savings account. So it's a type of interest. Now there's two types of interest we look at in maths. This is the first one. The other one is compound interest. And this interest is calculated in a specific way, and I'll show you that in the method. Percent means out of 100. Again, I'll keep mentioning that because it's very useful to remember. And annum means yearly. Okay? So in life, you will at some point need to understand interest. It is money paid to you via savings accounts or extra money you pay on a loan. You will have a given percentage rate in either case. All right, and that's set by whoever you borrow the money from or whatever bank you choose to use. Simple interest is calculated by working out the percent of the quantity for 1 year. Like I've said previously, it could be a different period of time, but mostly it is a year. Then you multiply by the number of years you need to multiply by depending upon what the question's asking you. Okay, so it might be a tricky thing to understand to begin with, but actually it's working out a percentage of quantity and then adding it on to a specific amount or taking it away potentially, but unlikely. Anyway, Z is investing £400 in his bank account that pays him a 1.25 simple interest per annum. Calculate how much he has in the account after 5 years. So we need to work out what 1.25% of this £400 is. All right. With these questions, we always assume that there's no other money being put in unless they specifically say as well, by the way. Okay, so let's take the £400 multiply by I could use the multiplier, couldn't we? Let's use the multiplier. So 1 plus, and then we put the percentage over 100. If you don't know what I'm talking about using the multiplier, go back and watch the previous video. I've just explained how to use a multiplier. So 1.25 out of 100. And then we'll find out what that is. So we know it's going to get £5 extra. You can see the difference between 400 and 400, and 5 is £5 per year. So £5 extra in interest for 1 year. All right. How much has he got in the account after 5 years? Well, again, like I said, just assume that he's not put any more money in that account. So that's going to be 5 times by 5, which is £25. Okay, that's 5 years times by the £5, £25. So therefore, the answer would be 400 plus the £25, which would be £425. Right? Relatively simple question, especially if we're allowed to use calculator for it. Okay, if we're not, we're going to have to take a lot more time, a lot more care and effort to work that one out. Right. Number 2, Aaron is getting a 5-year loan of £12,500 to pay for his new camper van. The loan is calculated with a 6% simple interest rate per annum. How much does he pay in interest over 5 years? So slightly more complicated. Pay attention here because we're only answering the question, how much does he pay in interest over 5 years, not how much does he pay in total. All right, so don't get caught out by something like that. So what we need to do, he's got a 5-year loan and he's got £12,500, right? That's quite a lot of money to borrow, and it's quite a high percentage interest rate, simple interest rate, but let's work out what 6% of that is, and then we will get what we need. All right, so I'm going to do it a slightly different way. Move the calculator over. I'm going to do the 12,500 multiplied by shift 6%. That's not what I pressed. Shift 6, shift, and then percent. That's what I meant to press. And that is going to calculate 6% of 12,500, right? So £12,500 multiplied by 6% is equal to 750 quid. So in 1 year, he's paying £750 interest. And so it's over 5 years, so 750 multiplied by 5 is the calculation that we need to work out there. So just times that by 5. £3,750. All right, so there we go. He's paying back, and if you wanted to know what it would be paying back, that is extra to the £12,500, right? And that's because he's got the privilege of borrowing the money. It wasn't his money in the first place, and that's what loans are, right? They will charge you an interest rate. Now, quite often we get slated as teachers and maths teachers. Oh, why do they learn all this? Why do they learn all this nonsense about nonsense, right? This is really practical stuff, right? Why don't they learn about interest rates? Well, we do teach about interest rates, right? Here it is. It's right here, right now, doing it. Okay, loans and interest rates of banks and things. I'm trying to keep things as much in context as possible. So there you go. Good question. Now, 3A, let's have a look at that. We've got 3B down there without B on it, I can notice already, but never mind. I'll just add that in. So, a savings account that offers a simple interest rate of 1.1% for the first year and states that if the investment in the second year matches the amount in the account at the end of the first year, they increase the rate 2.5% each year thereafter. How much would need to be invested in the second year to get the increased rate if Bessie's invests £4,500 in the first year? How much is the account after 12 years? So 2 questions. That one's B. We'll save that one for a bit. So the interest rate at the moment, 1.1%. Okay, pretty decent rate of interest actually, to be fair. Right, so that's just for 1 year. Let's see what would need to be in the account after that first year. So let's get our calculator in, and again, most of these you'd be allowed calculators for these sorts of questions. So 4,500 is what Bessie's putting in. Multiply it by 1 plus 1.1. Oh, I've got to press the fraction button first, haven't I? 1.1 over 100. That's not zeros, that's dots. And then that equals 4,000. I'll just write down what I did. That is 4,549.50. Alright, and then that's, so the first year, the investment. Second year matches the amount in the account at the end of the first year. So if the investment in the second year matches that, so she's got to put that amount of money in, right, in the second, at the end of the first year, and then she'll get an increase rate of 2.5% for each year thereafter. How much would need to be invested in the second year? So that is the answer to the question. That actually is it. I wrote this question. I wrote it a while ago and I've forgotten what it actually was. Right, but there you go. That is the answer to that question. Now, how much is in the account after 12 years? Well, if she has triggered that 2.5%, then she would have had to have chucked that amount of money in again. So there would have been that plus that. So let's take that and double it. So times by 2. Okay, so that gives you £9,099 in the account after 2 years. So then we're going to have to take off that 2 years. We'll take off the 2 years and have that as 1 plus, now this is a repeated percentage change question, really. 1 plus the 2.5% out of 100, right? And then we're going to have to the power of 8. Now I'll explain more why that works in a different video, right? But this is the number of years extra it is. Why am I putting 8? It should be 10. Right, because that's 12 take away 2, isn't it? I don't know why I was thinking 8. Yeah, that's the number of years extra, or the number of the time period. You can put whatever whatever time period it is as a power on the outside of this multiplier, and it will work out for you automatically. It's a really nice thing to be able to do. So take that, multiply it by 1 plus the 2.5. This is assuming she puts no more money in the bank account. Over 100. She's triggered that 2.5% interest rate, which is pretty good. And then she's got £9,326 and 48p. 9326 and 48p. That is how much money she would have in her bank account, putting that in the answer space there, after 12 years. Okay, because the first year she had £4,500 plus the interest that she earned there, which was another amount of money, £49.50. and that was a fairly decent thing to have. Then she matched it in the second year. At the end of the second year, there were 10 years left over, right? And that's why I used that power of 10. I don't know why I was thinking a power of 8. That wouldn't have worked. That was 2 years too less. All right, so there you go. There's how we do that particular question. Pretty tricky, that last one, and it's not quite everything that I've taught, or not. It's not the method that I've taught you up here. All right, but that's the point of these third questions. They introduce other things to you. So there will be a video on how to use the multiplier for repeated percentage change questions as well. I hope you enjoyed that video. Thanks for watching it. Please take care of yourselves, and I hope you watch some more. Bye.